way to work on this is to break it into small parts and then put it together to make this the equation. Okay, if I look at 5 less than, okay, this is a special case. If you say like 8 more than, that's addition. In addition, it doesn't matter what order you put it in, but whenever you say 5 less than or anything less than, it has to be minus that. So the minus will actually go before the number you're given. So just be really careful of that. Then we have 1/2 of is multiplication. Anytime it says a number, that's just a variable. We can use any variable we want. What letter would you like to use? S. Is equals, and then 2. Okay, so now we're going to put this together to make it coherent. 1/2 times S. You can just write it together like that. Minus 5 equals 2. Out. Okay, so 3 less than, it's going to be minus 3. 2/5 of is multiplication. I use X this time. Is 7. So again, 2/5 times X minus 3 equals 7. And with these two, because it says, 3 less than, 5 less than, the order matters. With this example, 8 more than, that's either plus 8 or you could say 8 plus. Because addition, it doesn't matter what order it goes in, right? 2/3 times y equals 20. So I can write this 2 ways. I can either write 8 plus 2/3 y, or I can do 2/3 y plus 8 equals 20. That's just a preference. It's the same thing. Put in the notes, but I'm just maybe just write it off underneath or to the side. If you see something like 5 times the sum, whenever you see something times the sum, that means, let's say, of X and Y. We'll just do that, okay? Anytime it's 5 times the sum, that sum is going to go in parentheses and the 5 is going to go on the outside. Or if it says like 5 times the difference, you're going to have that difference or the subtraction inside parentheses because it's 5 times the sum and 5 times the difference, not just 5 times X and Y. Does that make sense? Okay. Okay, in 1919, Britain and France offered a flight that carried 2 passengers at a time. Now there are approximately 45,000 flights each day in the United States, carrying 100 passengers on each flight. Carrying hundreds of passengers on each flight. In how many days will 180,000 flights have occurred? Okay, they're giving us information that's not really necessary here. We don't care about what happened in 1919, that their flight carried 2 people at a time. That's irrelevant. And we don't care how many people are on the flight, do we? What we need to know is that there are 45,000 flights a day, and we want to know how many days for 180,000 flights. Okay. So if I say the number of days, we'll call that D. So I'm going to say D. If I know that there's 45,000 per day what math am I going to do? Okay, I can do that. Multiplication, I can say 45,000 times the number of days is equal to 180,000. Okay, so that's one setup. The other setup I could do is I could do the total number of flights divided by the number per day. In any case, when you solve it, you would get 4 days. Formulas are just special equations. And in a formula, the letters have specific meanings and they mean the same thing every time. Okay. So area is the letter A, base is the letter B, height is the letter H. Always. Okay, so we're going to translate this sentence into a formula for the area of a triangle. So the area of a triangle, that's A, equals the product of 1/2 length of the base and the height. So it's all products, so it gets multiplied together. I like this. This is a large part of algebra. We're going to change that to say most of algebra is dedicated to solving equations. Okay, so what we have is the equation. It's not, you know, we say equals, but it's not really like in the past where you said like 2 + 5 = 7, and so it was like 2 + 5 was the problem and 7 was the answer. On an equation, it's more like this side is the same value as this side. It's like more of a balance beam or balance scale and less of a here's the answer kind of a situation. So what we do is we want to get the variable alone, so we use opposite operations to get the numbers away from the variable. So addition and subtraction are opposite, and multiplication and division are opposite. So we'll do whatever's there, and we'll do the opposite of it. So what's happening here is multiplication, right? So to do the opposite of multiplication, we're going to divide. And so we get x is -2. What's happening here is addition. So we want to do the opposite of addition, so we're going to do subtraction. And we get x is -1. And now no matter what you do to one side of the equal, you have to do it to the other side of the equal. Did you ever see that movie Lady in the Water?
Yeah, that was a good movie. It was with
yeah,
the man
that guy.
who did The Sixth Sense too, the director or
Yeah.
whatever. He did Sixth Sense.
Do you remember the guy that only lifted weights on one side of his body?
Yeah.
Did you see it?
Kind of.
Okay, well, and there's a character in the movie where the guy only lifts weights on one side of his body. So on like one side, he's got this giant, like Arnold Schwarzenegger, back when he was, you know, an actor, giant arm, right? And on the other side, he's got like a skinny, like me looking arm. And same with his legs. On one side, he's got this big giant leg, and the other side is like a normal skinny leg. That's what you look like if you don't do the same thing to both sides of the equation. You're no longer in balance, right?
So there'd be no solution.
Well, you'd get a false one. So you have to, like, if you're lifting weights, you want to lift weights on both sides, or you're going to look like that guy, and he looked weird. So it's the same thing with equations. You have to, everything you do to this side, you also have to do to that side, or it's no longer in balance. It's always about maintaining that balance, that this side and this side are the same. Even though they look different, they have the same weight or value. So here we have subtraction. And so the opposite operation is going to be addition. So C is 9. And here we have not a fraction, but division. Okay. And to get rid of division, we're going to multiply. So I'm going to multiply both sides times the denominator, 3, or the number being divided. And so I'm going to get x equals negative 24. Now, in single-step operations or equations, you might also get things like this. Okay. Now this can be done, actually, this can be done in a single step. I can multiply by the reciprocal. So this is method 1. And if I multiply by the reciprocal, these two cancel and these two cancel, and so I'm left with x. And I say 2 goes into 10 5 times, and then 5 times 3 is 15. If you don't like working with fractions, though, there's a second method. Okay. So I have 2/3 x equals 10. I can make this 2 steps. I can multiply by the denominator first, and I'm left with 2x equals 30. Then I divide by the numerator, and I get x equals 15. So if you don't want to have to work with multiplying a fraction, you can multiply by the denominator and then divide by the numerator. Okay, so we've got Hiroshi buying a pair of water skis that are on sale for 2/3 of the original price. So 2/3 of original price. He's using a $25 gift certificate. And then the total cost before taxes, $115. And we want to know what is the original price. That's our question mark. Okay. First of all, we're going to need to assign a letter to the original price. That's our unknown. That's what we want to find. So we'll give it a variable. I'm just going to use P for price. Okay. 2/3 of the original price is 2/3 times P. Now he uses a $25 gift certificate. And then after he uses the gift certificate, the cost is $115 that he has to still pay. So that means we're taking away $25 from the gift certificate, and that's going to make it equal $115. Okay. If we're solving multi-step problems, first we do the addition or subtraction. Then we do multiplication or division. Okay, so the first thing I want to do to get this isolated, I'm going to add 25 to both sides. So 2/3 P is 140. Do you want to do this in one step where you multiply by the reciprocal, or the 2 steps where you don't have to deal with fraction? 2 steps? Okay, so we're going to multiply by the denominator. So we're left with 2p, and that is going to be 420. Then we're going to divide by 2. And p is going to be $210. So this is how much the skis were originally, $210. So we've got some more multi-step equations. The first thing we need to do is add or subtract. So we're going to subtract 4 from both sides, which will leave us negative 2x is equal to 14. The next thing we do is divide by negative 2. So x equals negative 7. Come down here for b. We're going to add 4 to both sides first. So I get x divided by 7 is equal to 1. Multiply by 7. X equals 7. We subtract 14 from both sides. We get x over 9 is equal to negative 4. Multiply by 9. And you get x is equal to negative 36. And finally, we're going to add to both sides 17. And you get 3x equals 15. Divide both sides by 3, and you get x equals 5. Consecutive integer problems come up a lot. And there's 3 kinds. There's consecutive integers, consecutive even integers, and consecutive odd integers that come up. Okay. Consecutive integers, like if you pick a number, any number. Yeah, pick any number. 8, okay. So if I start at 8, my consecutive integers would be 8, 9, 10, 11, 12. Like you just count. So if you started with 8, to get to 9, you add 1. To get to 10, you'd add 1 more, so you have added 2 to the original number. To get to 11, you add 1 more, so you've added 3. So each number, you're adding 1 more each time. Consecutive even integers, if we start with 8 again, it would be 8, 10, 12, 14. Well, to get from 8 to 10, you don't add 1, you add 2. And then to go from 10 to 12, you add 2 more. And keep adding 2 each time, so it would be like 9, n plus 6, n plus 8, etc. You just keep adding 2 more each time. And it's the same thing with odds. If we start with 5, we go 5, 7, 9, 11. To get from 5 to 7, you add 2. To get from 7 to 9, you add 2 more. So with evens and odds, you'll add 2 extra each time. With just plain old consecutive integers, you add 1 each time. Now to do a consecutive integer problem, say find 3 consecutive odd integers. Okay. Well, we start with n always. The next odd number would be n plus 2. So that's 2 of them, and then we'd add n plus 4 to be the third one. So these are our 3 consecutive odd integers, and we want it to have a sum of negative 51. So what that means is I actually take these numbers that I just wrote down and I add them together. Right, so here's the first one, here's the second one, here's the third one. And that equals negative 51. If I add these up, I have 1, 2, 3 n's, and then 2 plus 4 is 6. So I get 3n plus 6 is equal to negative 51. And then just moving it so I have more space. If I subtract 6 from both sides, I get 3n is equal to negative 57. Then I divide by 3. N equals negative 19. Okay, but that just told me the first one. I need the consecutive ones. So if my first one is negative 19, my next one is negative 17, and then negative 15, because I'm doing odds. And you can test it. If I add these together, it's 51. So then I know I got the correct numbers. Consecutive integers, just plain old consecutive numbers. N plus 1, and n plus 2. And I want them to have a sum of 21, so I'm going to go ahead and add them together. Is equal to 21. So I have 3 n's plus 3 is equal to 21. Subtract 3 from both sides. 3n equals 18. Divide by 3. And n equals 6. And again, that only gives me the first number, this one. Well, that would be 7, and that would be 8. And if I add 6 plus 7 plus 8 together, well, I'll do 8 plus 7 is 21 plus 6 is 15, or sorry, 8 plus 7 is 15 plus 6 is 21. I know I did it right. I have a multi-step equation with parentheses. The first thing we need to do is distribute. So I'm going to do 3 times x, 3 times negative 2, and then negative 4 times x, negative 4 times 3. So I get 3x minus 6 minus 4x minus 12 equals 19. Okay. My like terms, I have 3x and negative 4x. If I add those together, I get negative x. And I have negative 6 and negative 12. So if I add those together, I get negative 18. And that equals 19. Okay. I've done the distribution and the collecting of like terms, so then I do addition or subtraction. So I'm going to add 18 to both sides. And I get negative x is equal to 37. Okay. I don't want to know what negative x is. I want to know what x is. So there's 2 ways to do this. I can either divide both sides by negative 1, which will give me negative 37, or anytime you have a negative variable, like this, just by itself negative, you switch both signs. So negative x equals 37 means x equals negative 37. You just switch both signs. Okay. Right. I'm just going to do a couple of these. I distribute this negative 2. Right, negative 6x plus 10 equals negative 26. There are no like terms to collect, so I'll skip to the addition and subtraction. So I subtract 10 from both sides. So negative 6x equals negative 36. Then I divide by negative 6. And I get x equals 6. Alright, so we'll skip to here and we'll do 5 times x and 5 times negative 2, 3 times x, 3 times 1. Okay, so that gives me 5x minus 10 plus 3x plus 3 equals 1. 5x and 3x is 8x. Negative 10 plus 3 is 7. If I subtract 7 from both sides, sorry, that's negative 7. I don't know why I wrote positive 7. So add 7 to both sides, and I get 8x equals 8. Divide both sides by 8, and you get x equals 1. We need to get like the letters by themselves on one side and then the numbers by themselves on the other side. So first I do the distribution just the same as I would do before. So I have negative 3x minus 24 plus 4x plus 36 equals 2x. Okay. I'm going to collect my like terms. I have negative 3x plus 4x, that's x, 1x. And if I have negative 24 plus 36, that's 12. Now, if there are letters and numbers on both sides of the equation, you have a choice as to which one you move. But in this case, I only have variables over here, so I have to move this x. So what I'm going to do is I'm going to subtract it from both sides. I'm going to get 12 equals x. If the subtracting letters from both sides is confusing, we can literally take this x, we can pick it up, and we can move it over here. However, if we do that, it's like the x is over here on this team, and now he's switching over to this team, and he cannot wear the same jersey if he switches teams, right? So you have to change the sign. So you can pick anything up, anything you want. Like I could have picked up this 12 and moved it over, that's fine too. I can pick up anything I want and I can put it on the other side, but if I do that, I have to change the sign. So this becomes 12 is equal to 2x minus x instead of positive x. So 12 equals x. So it's just a matter of preference. Do you like to subtract it from both sides, or do you want to move it and change the sign? It's the same thing, it's just looking at it in a different way. All right, so let's do these two at the bottom. If I take this negative 2 and I distribute it, I take this negative 5 and I distribute it. What I get is negative 4x minus 10 minus 10x plus 5 is equal to 15x plus 24. Negative 4 and negative 10 is negative 14x. Negative 10 and positive 5 is minus 5. Okay, now I have x's and variables on, or variables and numbers on both sides, right? So I choose, do I want to take this 15 and put it over here with the 14 and they'll both be negative? Do I want to take this 14 and put it over here with the 15 and they're both positive? Preferences? Positive? Okay. So do you want to add it to both sides or move it? Add it? Okay, so I'm going to add 14x to both sides so that it stays positive. So I get negative 5 is equal to 29x plus 24. Now that I've moved the x's over here, I have to move the number away from it. So I subtract 24 from both sides, and I get negative 29 is equal to 29x, which I'm going to just kind of rewrite right here. And I'm going to divide both sides by 29. And x is equal to -1. On this problem, if I do the distribution, I get 5x minus 10 plus 3x plus 12 is equal to 8x. If I collect like terms, I get 8x plus 2 is equal to 8x. Now I'm going to subtract 8x from both sides. And I'm going to get 2 equals 0. Do you guys see a problem with that? Okay. When this happens, there's no solution. Okay. If you had gotten like a true statement, for example, like 2 equals 2, then it's all real numbers. So you're solving along, you're doing everything, and then you get something that's absolutely a lie, your answer is no solution.